Record linkage is linking records associated with the same exact entity. There are other statistical techniques that can be used for doing analysis of data which do not require the linkage on the same entity. One of those is statistical matching, where the idea is that you're linking with something which is similar but not necessarily the exact same. And linkage is based on the comparison of similar fields, and it's also related to deduplication, linkage of a file back to itself. Or I should just say that deduplication I would think of as linkage of a file back to itself. It can be more complicated than that. There could be additional features to that process, and it can also be called entity resolution or deduplication. So now I'm going to look at the different methods that are used for linkage. So something we had just been hearing about was the question of, how do you do the linkage? You can very simply link on a unique identifier. That is one type of deterministic linkage. It's very straightforward. It doesn't require the statistical model, which is used in probabilistic record linkage. I mean, it's great if you have a unique ID, which you can rely on, then it's, you can't do better than that. A lot of times in the data we work with, that's not the case, but there's also the problem is maybe there's errors in those keys. And so you may include validation in that process. And generally, when I'm thinking about record linkage, I'm thinking about probabilistic record linkage. And I'll go into that a little bit more depth on the next slide. And there's also alternative strategies for doing linkage, which I'll also cover on the next slide. So probabilistic linkage implies that there is an underlying probability model, and kind of the traditional method which was used was formalized mathematically by 𝐏𝐚𝐬𝐿 and Sunter in 1969, and is an approach which is used by statisticians. And more recently, there have been Bayesian models, which are more advanced methods, and I'll look at comparing how they work. And there's also alternative strategies, just showing they could use a classification tree or microclustering. I'm sure there's others which people can tell me about. So right now I'm going to focus on the probabilistic linkage methods. And the first method is, again, the 𝐏𝐚𝐬𝐿-Sunter method. And one of its high points is that it's simple. And it was proved by 𝐏𝐚𝐬𝐿 and Sunter that for a simple scoring model, it comes up with optimal discrimination between what is a true match, actually what we just call a match, and what is a non-match, two records that don't represent the same entity, be it a person or an organization or something else. And there's a lot of software out there which can run the 𝐏𝐚𝐬𝐿-Sunter models, and so that makes it easier for someone to implement this kind of thing. And it's very effective for large file sizes. Now, Bayesian methods, they use more complex models, and they can include the use of variables which are not used for direct comparison. As far as I'm aware, people can correct me if they know differently, but sourcing of software is challenging. And a lot of these analyses, because of the more complex models, take long run times, and the file sizes that they could be run on are more limited in size. But Bayesian also has the advantage that it enables appropriate multi-way linkages, and that could also be important for a deduplication operation and the computation of posterior probabilities. What is the probability that a pair is a true match? I will say that even on 𝐏𝐚𝐬𝐿-Sunter, that is to some degree feasible, but it's mainly on a pairwise basis, not on an aggregate basis. I'm going to focus on the 𝐏𝐚𝐬𝐿-Sunter, and the main reason I'm focusing on it is because that is what I know the best. I'm going to talk about how the linkages, essentially linkages between records in two files. There's a pair formation strategy, and one record from file B, and I'm going to make it into something I want to analyze whether they are the same. And the normal strategy, which is used, is blocking, and we'll talk about blocking a little bit later. And once you have those pairs, you're going to do the evaluation of whether you think they are a match or not a match. That is, whether they or not they represent the same entity, or they don't agree with each other. And just to give you some examples of comparison variables that we would use with person-level data, this would be patient record data, is dates of birth, and we would look at the components separately, month, year, day, the names, that could be first, middle, last, address components, and certainly there's flexibility to use other pieces of information, but these are some of the most typical that are used for person-level linkages. And so associated with each of I call it a comparison set because the variable on one file for first name obviously may have a different name than the variable on the second data set, which also has first name. So, but for each of these sets, there is an agreement and a disagreement weight, and they're set by some heuristic, which I will talk about in a little later. So what you're going to do is for each of these comparisons, so say we're working with first name, you're going to look whether they agree or they don't agree. Now, you say that's very simplistic, and it is. You actually can do a lot more. You can do string similarities, you could do sound X, all types of things like that. But for the sake of simplicity, we'll just say it's a binary outcome, which is they agree or they don't agree. And if they agree, then the variable weight becomes the agreement weight, and if they disagree, it's the disagreement weight. And then you're going to sum those variable weights across all of the comparison sets, and you'll come out with a total score, which is called the pair weight, and you're going to compare that to a threshold, and that determines whether it's a match or not a match. Setting the threshold is also another question. There are heuristics for setting the threshold. When I worked at the Census Bureau, we actually set the threshold manually, which I don't recommend, but that's certainly one procedure which can be done. As I said, your pair formation strategy, ideally, every record on file B. If it were a deduplication, it would be every record to every other record. So this is, if you have large files with millions of records, which we often do work with files of these sizes, then comparing all the records on the two files just makes it too difficult to conduct the processing. So the standard workaround is the use of blocking. And blocking, you're going to come up with multiple blocking passes, and each blocking pass is going to break up the file into blocks, and then you're going to only do comparisons within the blocks. And the most simple way of doing the blocking is just by a key, and so the key could just be first and last initial of the names. That would be an easy blocking key. There's more complex methods such as k-means, which I'm not going to get into. But one thing from a computing perspective is that once you have determined what is in each block, it's very easy to process these in separate processing streams. And I did add as a note that the data engine for forming pairs is critical for efficient processing. We tend to use statistical programs for doing this. So I know that, for example, like R uses data table as apparently an efficient database engine. Some are better than others, but this is going to be a critical factor if you have a large workload that you need to get through quickly. So now we're going to talk about computational approaches. The question is, well, how do you set these weights? Well, the weights are formulaically related to what we call the M probability, which is the probability that a field agrees given that they represent the same entity. So what is the probability that first names will agree given the records represent the same person? And what is the probability that they agree even though they're not the same person? That's spurious. It's going to be much lower. That's called the U probability. And we use a machine learning and unsupervised method called the expectation maximization algorithm to estimate these. It's actually not that complicated to code, but if you have good record linkage software, it should be able to do this for you. And I don't think I have the time to give you more detail on how it works. And another place where machine learning can be used is the development of a blocking strategy. And the importance of it is, well, if I block on first and last initial, well, clearly someone's changed their last name, we won't pick them up in a block. So we need multiple blocking passes in case we miss them in one. And how do you arrange these efficiently to get the most of the true matches being found without causing excessive run times? And we use something called the sequential coverage algorithm, which is not truly an optimization routine, but it generally finds an effective strategy for blocking. And we do use it effectively at the National Center for Health Statistics. And some other features of linkage design, I talked about partial string agreement. We use a similarity measure developed by Winkler, Giroux, and who were researchers of the Census Bureau. You may have heard of Levenshtein distance. You can also use sound encoding like NISIS or SoundX. The probability model assumes agreements between variable sets are independent, and it's actually the case that if there is not independence, that can really cause major problems to your fit. Data editing, just like any kind of data analysis, the editing is critical. And we also use nickname lists, and name frequencies in particular is quite helpful. So the idea that you see two records and they have a shared last name, which is uncommon, should give it a higher score and more likelihood that it is a true match. So these are a few techniques. There are definitely others which can be used to improve linkage quality. Okay, I'll take the questions. This is my contact information. Feel free to contact me if you have questions about the topics I've discussed in this talk and just some background material on my company. Thank you.